Select the missing starting material required to accomplish the following transformation. So if we look at this product, so what we can see is that we have a beta hydroxy aldehyde. And so hopefully we can recognize this as potentially being the product of an aldol addition reaction. So alpha, beta. So when you have this aldol addition reaction, it's a way to bring together two molecules of an aldehyde. So you convert some of your aldehyde to the enolate, some of it remains as the aldehyde, and that is how they come together, since one would be an, if one is converted to the enolate, it would be a nucleophile, and the remaining aldehyde would be the electrophile. So this is our new bond that we're forming in this reaction. And so we want to do to figure out what aldehyde we brought together here is we just want a number. So we can take a look and see that we have, you can see clearly we have an aldehyde here. So 1, 2, 3, 4. So this side is the side that was the nucleophilic side. And we can see that because the new bond is to the alpha carbon. And we make an enolate. The alpha carbon is the one that is nucleophilic. And if we look on the other side, we can see the same 1, 2, 3, 4 carbon atoms. And so when you form an enolate and attack the aldehyde on the other side, you can break the pi bond, so you can end up with the alcohol. So from this, we should be able to see that it looks like we had a 4 carbon atom aldehyde. So we have 1, 2, 3, so we need one more, there's 4. And so if we want to test this to make sure, we can go ahead and draw the mechanism. And, so kind of cover up the answer that you got and draw the mechanism of that self-aldol addition reaction and make sure that it does actually give you what you're looking for. So you say, okay, well, if we take this aldehyde and we treat it with sodium hydroxide, some of that aldehyde will be converted to the enolate. And so I'm going to go ahead and this time I'm going to draw the enolate with the negative charge on the carbon, just so we can clearly see where our nucleophilic carbon is. So most of this will still be the starting aldehyde because this acid-base reaction doesn't proceed very far in the forward direction. So let's go ahead and draw that enolate. So there it is. So we have some of this converted to the enolate, which means we still have a large amount of this aldehyde around. So this is the nucleophile. And if we have more of the aldehyde, 1, 2, 3, 4, 1, 2, 3, 4. So then we can have this nucleophile, this enolate nucleophile, react with the electrophilic carbon of the aldehyde carbonyl. So we can form a new bond there, and we're going to push electrons up onto that oxygen. So we can see here we've got 1, 2, 3, 4 carbon atoms, and on the other side we should see 1, 2, 3, 4 carbon atoms. And so if we want to draw our aldol product, this was our nucleophilic carbon. So I'm going to go ahead and draw that. All right, so there's the nucleophilic carbon. And so the new bond came from that. So 1, 2, 3, 4. We'll put those carbon atoms angled like this. So 1, 2, 3, 4. And so we're recognizing that we formed this new bond between this carbon 2 and this carbon 1. So let's go ahead and draw that new bond, and just trying to find a different color to draw it in. So we use that one. And so after you have attacked this carbon, you've broken the pi bond, so you just have a single bond to oxygen. There's still a hydrogen attached to that carbon. You can draw it if you want, or you can have it be understood to be there, which is what I'm going to do. And then you can also draw the remaining 3 carbon atoms. So 1, 2, 3. And we're going to go ahead and number those. 3, 4. So it certainly looks like we've brought together 2 4 carbon atom pieces. And then with water as your solvent, you can add the proton to that alkoxide in order to get the alcohol. And And so it certainly looks like this is going to work to give us the product that we formed. Okay, so the fast way to decide would be to identify that new bond, number your carbon atoms, and then to check your work, you're going to cover up your answer, draw the mechanism of the forward reaction and in the forward direction, and make sure that's giving you what you want it to. So we can recognize this 4 carbon atoms as being option D here. So that would be the correct answer.